Okay, so here I'm going to prove the Heron's formula. So when you first look at this, it looks pretty crazy, but really, it's actually pretty simple. So first you need to know that cosine of c is going to equal a squared plus b squared minus c squared all over 2ab. And that just follows from the law of cosines, but you can simplify yourself to see and prove that. And then, down here, this is just the result of sine squared of angle plus cosine squared of angle equals 1, which we proved in class, so I hope you understand that one. And then we'll solve for c and solve for sine of c and get sine of c equals the square root of 1 minus cosine squared of c. Then we'll just substitute this right in, and we'll get this expression over here, which, well, yeah, I think it's pretty simple to get. You just create a common denominator, then you just write it all into a denominator, and pull this 2ab out because it's going to be 4a squared b squared. And so that'll be pretty simple. If you don't get that, just try to write it out yourself, and I hope it'll look pretty simple after that. Okay, and also, something that we've kind of went over in class, but not really, is that the area of a triangle is 1/2 AB sine of angle, which I kind of proved down here, because the area of a triangle is the base times height, 1/2, well t is area in this case. And we know that sine of c equals h over b, which then we multiply out to be b times sine of c equals h. And we substitute that back into the equation, we get the area equals 1/2 AB sine of c, and that's a quick proof right there. So now we're going to go up here into this big long mess over here. Try to simplify this out. So 1/2 AB sine of angle, we'll substitute this in. Over here, sine of angle equals the square root of 4a squared b squared minus quantity a squared plus b squared minus c squared squared, which is kind of a mess, which will go over 2ab. So if you substitute that in, you'll get, these ab's will cancel out, and you'll get 1/2 times 1/2, which equals 1/4, multiplied by this top part right here. And here, we'll actually just use this right here, the sum and difference. Well, you multiply squares. So if you have two squares, like, let's see right here, ab times a minus b equals a squared minus b squared. So we'll just use that property in reverse right here, and get the square root of 4a squared b squared equals 2ab, and the square root of that equals a squared plus b squared minus c squared. So let's put that in there, and that will be, and we'll actually continue doing this whole thing throughout this process. This will happen a lot. So right here, we'll put this 2ab term in between negative a squared minus b squared, and we will get this, and then we'll add c squared. So this is equivalent right here to this down here, and the same thing will happen for the other side. And then we'll use this square difference right here again to get c minus parentheses a minus b parentheses c plus a minus b, a plus b minus c, and a plus b plus c. Then we'll simplify this out to get this, and then we'll actually split the 16 up into 4 different parts. So we'll get b plus c minus a over 2 times a plus c minus b over 2 times a plus b minus c over 2 times a plus b plus c over 2. And then down here we're just going to reorder this into the form you usually see. And here comes the part that's a little trickier, but I think it was pretty easy. Since we know that s is a plus b plus c over 2, so right here, let's, for example, the second term right here, b plus c minus a over 2 equals s, because we'll just add, let's see, how do we do this? So b plus c minus a over 2 is a plus b plus c 2a, actually, over 2, well, actually it should be a b, it's 1a, minus 2a, that over 2, whole thing over 2. So we'll only get a plus b plus c over 2, and then minus a. So that'll be s minus a for that one. And you can do the same thing for all these other terms to get the square root of s times s minus a times s minus b times s minus c. And that is how you prove Heron's formula.